Okay, so I'm going to make this a high-level overview of what is predictive maintenance and how it applies in heavy industrial settings. And hopefully this will, including mining, hopefully this will be helpful to people. First off, the agenda, who are we? We're going to have discussion on AI, ML-based PDM, case studies, conclusion, and a Q&A. First off, I'm David Peterson. I'm based in Utah, USA. I have a degree in mechanical engineering. My background is in mining, aerospace, and metals. I currently work as a predictive maintenance specialist with Senseye, and I didn't put this in here, but I have spent about 4 years of my life in Japan. I speak, read, and write Japanese in doing some of the engineering in heavy industry that I worked with. Okay, so first, what is Senseye PDM? PDM is automated predictive maintenance. This is a software tool designed for rapid deployment. Typically, people will try to get a data scientist in and they'll create a model for a specific type of an asset. And that may take 6 to 9 months to develop a model that may not necessarily apply equally across different types of models. For instance, I may have a jaw crusher that's working in one location and it's doing relatively soft materials. Then in another location, it's maybe 50% silica content, and it's much harder to crush. That same model isn't going to work for both of those types of applications. So everyone talks about, we want to go into this digital transformation. Everyone wants to talk about how can they move from a traditional mining operation into something that includes AI, artificial intelligence, machine learning. They may have a variety of machines, everything from a 30-year-old machine to something they picked up 2 weeks ago that has an edge device. So the questions, the challenges are, how do we maintain uptime? Others may want to say we want to reduce unplanned downtime. They want to make sure that the maintenance they do is precise and correct. They don't want to be spending time going out and doing maintenance on something that doesn't need it, nor do they want to maintain the wrong item. For instance, you may be monitoring something like an ID fan. Well, is an ID fan only an ID fan, or is it a fan, and is it a filter, and does it have a gearbox, and does it have a motor? So you may have different kinds of items that you could maintain. You want to make sure that whatever the main maintenance is at the correct location and is very precise. You want to reduce operating risks and operating costs. What I mean by risks is it's not a good thing to have humans in heavy industrial settings. Anytime you get humans into certain areas, you increase the options for potential problems with health and or safety. Also, the more people you have to send out to do something that is preventative maintenance rather than predictive maintenance, that increases your operational costs. Also, with COVID, you have a lot more people who are trying to work remotely, or you may have multiple locations. You may have, under a single organization, you may have 30 different locations where you're doing mining. It'd be nice for a maintenance manager to be able to understand and see the health of the assets, the health of the machines, wherever they happen to be, anywhere in the world. And we want to be able to support that remote work. Several of our customers do exactly that, to where a maintenance manager will actually direct the work from a central location because he has access, or she has access, to seeing whatever needs to be done. And we want to increase sustainability. One thing I didn't tell you was that I used to have a mining company. I owned a mining company. We produced calcite. And if something went down, if we had maybe a bag house went down and I was blowing all sorts of dust out into the environment, then that was a problem because I hadn't anticipated the downtime. Anytime we talk about increasing sustainability, we're talking about avoiding fines. We're talking about increasing decreasing the footprint or the impact on the environment where we're operating. So these are the challenges we face. In addition to that, it's compounded by scalability. What if I have 5 different locations that I'm trying to maintain? How do I scale that easily over multiple locations? Also, how do I scale a predictive maintenance model across all assets? And let's go ahead and define what an asset is. Some people may talk about an asset as being a machine. A lot of people don't understand. Even within the industry, there's debate on how how we define an asset. We like to take it down to the lowest common denominator, meaning a pump. Well, a pump may be involved in a number of different locations, but that's something that we can monitor. We want to take the lowest possible independent asset that we can monitor. Another problem is data silos. You may have different systems, maybe different a SCADA system or PLC or something where you don't necessarily have access to all the different data, and they don't talk to each other. There's also a skill shortage. This is also another thing that was worsened with COVID. You had a lot of people who decided, I'm going to retire. And you have new people coming in that don't necessarily have the same skill set as the master with 30 years of experience. There's a low adoption rate. A lot of people in the industry are scared of AI. They're scared of making that digital transformation. What will it mean to my job? What will it mean to this system? Is it going to be hard to learn? And so you have a lot of inherent cultural issues to overcome, where you try to help people understand this is actually improving your lifestyle. It's the equivalent of adding time back into your schedule because you don't have to do all sorts of PM that was never needed in the first place. Then it also, the other thing is, how about collaboration and engagement? Can the different locations talk to each other? Can they learn from the alarms from each other? If they find a problem and they face it, they can share information with the collaboration and engagement. Okay. So what are the barriers? Siloed data. Maybe you don't have a CMMS system in use. Maybe you don't have historical data, no historian. Maybe you don't have connectivity on site. Those are all things that can be overcome, but that is a barrier. What about resource allocation? You don't have enough manpower or effort to make a change. You don't want to go hire a bunch of data scientists. We understand. Maybe there's security concerns. One of our customers is very heavily into the uranium mining vertical. They don't want a lot of information being shared. We want to make sure that all information is 100% secure, and that it is, so if you're having data that's being produced, you want to make sure it's completely secure. What about legacy systems? How do you get old legacy systems in with the new edge devices? And as I mentioned before, there's cultural resistance. Sometimes people are scared of bringing AI into the heavy industrial setting. So what do we want to do? What we want to do is we want to use the existing data. A lot of the machines that you've bought coming from the factory, they come with pressure sensors or maybe torque sensors, or maybe they're measuring amps or any number of temperature, any number of things. Pardon me. You don't have to have the most exotic vibration sensor to get data on predictive maintenance. Leverage what you already have. See what you can determine based on the information that you already have, and use that to your advantage rather than spending millions of dollars on sensors that aren't necessary to need. You want to optimize other aspects of the business. You want to make sure that you can make better business decisions, and you want to be able to measure KPIs by utilizing Senseye automatically. And when I say automatically, all we do is set it up correctly, and the KPIs are measured exactly how you like them. What we like to say is we can work with any asset of any age, anywhere. I would also add to that, I can work with any sensor, any CMMS, and any historian. I can display the information on any browser, so whether it's a computer or a tablet or a laptop or even a phone, and that's maybe a little bit tight on a phone, but I can display the information on any browser. We like to say that we are sensor agnostic, and that we can display the information anywhere we need. So on any type of asset. So how does the data flow? Well, over on the left-hand side, we call it the factory flow because we're in multiple verticals. We're in everything from bottling to mining to metals to CMMS. I'm sorry, to FMCG, the fast-moving consumer goods. So we just use a factory floor as a generic way to say it. That could be a mining location. And you have all sorts of sensors that are already on the equipment that you have on site. Most people don't realize how much sensors they actually have. Or you might have edge processing. Well, a lot of the information is generated and it'll go into some type of a platform and historian. Could be Azure, could be IBA, could be OSI Soft. And from there, we go ahead and send that information. Senseye exists exclusively in the cloud. What that means is that anytime we want to make a change and we update our algorithms every 2 weeks, we make refinements all the time. You never have to worry about updating it on your site. It is done automatically. And if let's say you want to push data into the cloud, we can actually just make a digital twin of that. It's easy to do. We do all of the integration. We do all of the artificial intelligence, machine learning, the predictive maintenance there inside the app. We automatically monitor your machine health. Then we'll send out notifications if there happens to be a problem. We'll send it out to your, maybe the CMMS. We, over on the left-hand side, we talked about that. We say SAP, it could be anyone. As I said, we work with anyone, including in-house special CMMSs. We've worked with those as well. And then it goes down to the maintenance team. They'll do work, and based on the work, the information they put back in, it'll go back to Senseye and create a better workflow. It actually begins to improve the algorithm. So for instance, on the left-hand side, you'll see the data sources. I'm going to get condition monitoring. You know, maybe I have factory historian, the IoT platforms. Down below, I have operations or recipe. Let's face it, in a mining situation, you may be mining different rock hardnesses or different types of ore throughout the course of a day. You want to make sure that you understand the process and the recipe at the time. Also, the maintenance data gets involved, whether it's preventative maintenance or corrective maintenance or reconfiguration. All of that gets taken into account, and those are the three main sources of data we use to create information, to create the predictive maintenance. So what kind of data is helpful? What is good? What is not bad? We want to make sure that we're getting the right type of data. There is something that is important to understand is we want to get something that's above 0.2 hertz. If you look on the left-hand side, the fourth one down, we don't need data every second. In fact, that creates way too much noise. I may want to take it maybe every 5 minutes, maybe every minute, maybe every 10 minutes. And get myself a min, max, and average. And that way I can track a lot of the issues that are coming up without the raw data getting involved, getting in the way. On the left-hand side, we see all the type of data that are not ideal. On the right-hand side, we can see data that is ideal. We want to make sure that we have current, torque, pressure, vibration, temperature, speed or voltage. We like to see aggregated data, you know, min, max, mean, rate of change. Those are things that are very helpful for us to understand the machine health. And we also like to make sure that we have the ability to send information to the cloud. We don't do on-prem. We do have customers that have, on occasion, they've used a spreadsheet where they'll send us a file at the end of the day, and we just use that instead of actual connectivity. Okay, so how do we solve the problems? Scalability. We are specifically designed to monitor tens of thousands of machines automatically. It is not unusual for us to bring on, say, 10,000 assets in the course of 6 months. It's not that big a deal. We want to make sure that we don't have data silos. We use open APIs and proven integrations and partnerships with industrial leaders. As I said, we can work with any CMMS, any historian. We want to make sure that the skills storage is helping humans to prioritize where they need their attention. So the program will let you know, hey, there's a problem in this area. Look at this particular item. Here's some corrective action you might want to take. We help someone who might be new in the industry understand what to look at. So for instance, an example might be, hey, we have a problem. We have increasing torque on this particular pump. And based on the way that the graph looks, we'd say, oh, go check the non-drive inside of the bearing. and go ahead and grease it or give it a visual inspection to see if it needs to be changed. That's not something you want to ignore. If the bearing happens to go out, you might be ruining a bearing housing or bending a shaft. You want to take care of the right thing in the precise location at the right time. For the low adoption, you have people who are nervous about this. Our team actually will lead your maintenance team. They'll take them by the hand. And every week, what we do is we simply sit down and say, this is what the graph is. What are you looking at and what does it actually mean? What it means, here's how to interpret the graph. Some people look at as AI as a magic pill. It does everything for you automatically. Well, that's not true. You get into it, or you get out of it what you put into it. You have to put effort into it when we first put it in place. You have to set it up correctly. But once it is in place and the data keeps coming back to us and the maintenance events come back to us and we refine the process, we begin moving from a predictive maintenance to a prognostic maintenance where we want to optimize the absolute OEE of all assets. We don't want to leave we don't want to leave life on the shelf by having to move things out. Also, collaboration and engagement. We have Microsoft Teams integrations. You don't even have to log into the program. You can actually just sit on a tab in Teams. I'll probably skip this slide. This is nerdy stuff. Basically, we're saying is we actually understand what's going on. We understand how to do things. We understand the process. Over 35% of our company have PhDs. We are very able to understand what we do. So just quickly here, we'll try to move through quickly. We want to make sure that we're understanding, is there an anomaly? Nobody wants a false positive. Did someone just happen to walk by and bump the machine? Well, let's go ahead and find out if that's what it is. Did a trend develop? Was there a step change? Maybe there was a regime change there inside the system. Was a threshold exceeded? What about diagnostics? How are we going to look at diagnostics and forecast on that? And is the machine life degrading over time? And if so, can we match previous failures so that if we establish a baseline, and we can establish a baseline operating condition within 48 to 72 hours of any asset. We don't need 6 to 9 months to have a formal item done. We actually do that automatically within 48 to 72 hours. So any deviation from the norm is easily detected and brought to the attention of the people who need to know where to go and what to do. So question arises, well, what's in it for me? How long is it going to take? Deployment typically takes around 3 to 6 months, depending on your company, how quickly you can devote time to it. How long does it take to get an ROI? Typically, or what type of an ROI would be expected from implementing some type of an AI PDM system? It would be easy to expect between 3 to 5x. We've seen as high as 10 to 20x. Downtime reduction, it's not unusual to get anywhere between 10 to 20%. A couple of quick examples. We work with a leading global provider of uranium since 2020, as they advance towards the global or the digital transformation. It took them about the initial deployment was covered in 9 very complex mining assets. They wanted PDM as a managed product. They wanted efficient implementation to enable to get quick results. So one thing that I didn't point out in this is they did not have to hire a single other person to run this, nor did we. This is automatically done with the program, with the application. Additional sensors installed? None. We didn't have to add any additional sensors. We used the existing sensors that are already coming in most of these OEM manufactured machines. ROI in 2021 was achieved in 9 months. So we're currently expanding from the first site to 2 additional sites for an additional 200 assets. Okay, another one we work with is Alcoa. They achieved their ROI in 3 months. Once again, the left-hand side going down there, how many new people did they have to hire for the deployment? None. How many additional sensors were installed? None. The ROI in 2019 was 10x. They achieved that in 10 months. They reduced their unplanned downtime by 20%, which is a significant improvement in the operational efficiency of their equipment. Currently, we're at over 1,000 assets covered in the Fjarðaál location there in Iceland, and we have global expansion currently in progress. So this will be real quickly here. On the left-hand side, what do we want to do? We want to utilize the expert machine knowledge. We want to perform data processing, offstate removal, aggregation, transformations, all that stuff. And we can either use OSI Pi, or we can actually do it in, like, say, an IPC, something of that nature, if you don't want to use additional Pi tags, because Pi tags can start costing money. We can do it in any number of different ways. We want to take the data, establish complex rules. So an example might be on the right-hand side. Hey, let's raise a case on asset X if 5 consecutive raw data points exceed the value of 10. Or raise a case on asset Y if the hourly value increases 3 or more times in a span of 2 days. In other words, it's not magic. We just have to understand what it is we want, and when we don't want false positives, but we also don't want to ignore it if thresholds or anomalies or trends are being discovered. Okay. So we can put in things like, raise a case on asset Z if the pressure exceeds 2,500, the velocity exceeds 80, and the temperature exceeds 100. You can add all sorts of complex cases with derived measures that make it simple so that you're not spending time trying to understand the asset. It's done automatically for you. Okay, these are some real case scenarios. I've changed a few things so it doesn't, so we're not giving away too much information. We had problems with spikes and vibration around the same time of day, every day. You can only one of 2 fans. Pardon me. The fan had been experiencing previously unexplained peaks in vibration at the same time every day for months. No one knew the cause, and another fan of the same type in the same location wasn't experiencing any rise in vibration. So they looked through it and they found out that basically it was related to temperature. We went out and took a look at the non-drive end, and they found the problem. And you can see that very easily in the graphs that are there. Once again, if you don't get nervous, if you can't understand the graphs, what our team does is we literally show you day by day, week by week, on what the graphs are supposed to be meaning. Another example, this would be a furnace conveyor motor. It was a contaminated problem. We looked at the graphs, we saw the problems that were coming up with the water flow average. We locked out, and so on the actions, you can actually see the type of maintenance that was done, and that becomes part of the physical record, and actually gets information such as this would helpfully be included in the refinement of the process. Okay. I'll skip through that there. Conclusion. Industry 4.0 boosts operational efficiency. A lot of people are scared to do the digital transformation, but once they do it, then they'll never go back. It's amazing how what scares us is actually the thing that actually brings us more time and a better quality of our work life. Combining multiple data sources with smart technologies is just making better business decisions. It does require shifting culture. There's no more data silos. It actually helps your team work together very well. And you want to make the most of the data that you already have, you're already collecting. If I was to put an estimate on that, I would say that 80% of all the data that's being generated out there is never even looked at. And if it is looked at, most people don't understand what they're looking at. What we do at Senseye is we actually try to help you understand exactly what it means and how it can benefit your life. Okay, so thank you very much. And there you go. If there are any questions, I'm willing to take those now.